Okay, so hello everyone. My name is Daniel Starnowski. I came from Poland. I'm one of the Mikrotik trainers. And the presentation, as Norvis mentioned, will be about the switch chipsets in Mikrotik Routerboards. Just a minute. Okay, because switching chipsets, as I heard, is a difficult subject to some people. It is very simple. And I don't know why so many people ask me about the switching, how does it work on Mikrotik routers, because they don't know how to use the internal switch built in. So this presentation will be about it. If you successfully use the switching chipset on your router board, and you know how to do the vlan trunking on it, you will probably be bored with this presentation. It will be short and it will be very easy. This is just an example of router board. This is RB 2011. We have some Ethernet ports, some gigabit ports, some 100 megabit ports, an SFP port, and there is underlying word router, because it's router board, and it is mainly designed to be a router. And as you know, there is a difference between routers and switches. Switch is a very simple and usually cheaper device that operates on the second layer of the OSI model. And it just takes the Ethernet frame and just forwards the frame to other port. Just looks at the destination MAC address and directs the Ethernet frame to proper port. Router is a more complicated device, usually more expensive device. And it has a processor unit that makes more complicated decisions about the packets. At first, it decapsulates the packets. It takes the IP packet from the Ethernet frame and then packs it to other Ethernet frame on different port and sends it to other device in the network. So there is a difference between switch and router. And Mikrotik router boards are primarily meant to be routers. So if we look inside our router board, this is RB 2011, but it could be router board 751, 951. Many of you probably got your free router board yesterday or today in the morning. So it looks almost the same in the middle. The physical ports are connected by some internal virtual wires to the CPU. And for example, if we set an IP addresses on the Ether 1 and Ether 5 ports, we can do a routing between those local address networks. So in this example, we have the network 1.0/24 on Ether 1 and 5.0/24 on Ether 5. And the packets from one network just go to the CPU, and then the CPU decides what to do to them. And if they should go to the other network, it just passes them to the other network. This is how routing works. But sometimes we want few physical ports to be in one local network. So when we don't want to buy another small switch, we can use the bridging feature of the router OS just to connect the two physical ports to one bridge. You know that on Mikrotik this is very simple. You can even add an IP address to the bridge. So you just create a bridge interface. You just add two ports, Ether1 and Ether5, to the bridge. You add IP address on the bridge interface, and that's all. That's how the virtual switch is created. But all the packets now are also going through the CPU. And as we know, CPU is a very tired machine, and sometimes it's not too powerful to serve all the packets. These are a few examples of the bridging performance. These are examples for Routerboard 2011, and they are based on the official Mikrotik measures. They are quite okay. If you use the fastpath feature, so we have no bridge filters, IP filters, no QEs, just a simple bridge, we can get about 1.5 gigabits total traffic going through the CPU with bridging. But it's only for the large packets. It's only for 1,500 bytes packets. If we use the small 64-byte packets, the total performance of the bridge would be about 150 megabits and nothing more, because the CPU is going at 100% and cannot do anything else. So the CPU is our limitation. Without using fastpath, it's even worse. With the small 64-byte packets, we can only transfer about 50 megabits per second of traffic, and the CPU is totally overheating, it's 100%, and it cannot do anything else. This is an example for Routerboard 2011. Another example, if we would like to use to bridge VLANs. This is a simple example. I have two trunk ports with two VLANs on Ether1 and Ether2. I have tagged the VLANs numbered 33 and 44. And I have also some access ports to those VLANs. So Ethernet 3 is access port to VLAN 33, and the same is for Ether4. So on Mikrotik, I need to create a VLAN interface for each VLAN, for each physical port. To do it, for example, for VLAN 33, I create a VLAN 33 Ethernet 1 VLAN interface on Ether1. I create similar VLAN interface on Ether2, and I create a bridge interface called VLAN 33, and I put all the three ports, VLAN 33 on Ether1, VLAN 33 on Ether2, and the Ether3 untagged port, all those three ports to the bridge called VLAN 33. This is how I bridge the VLAN 33 using the CPU. And I must, of course, do the same to the second VLAN. I did the test, performance test of this. I used 8 different UDP streams. So the packets were going through from Ether1 to Ether3, Ether2 to Ether3, and backwards, and the same for the other VLAN. So I had total 8 UDP streams, equally distributed between the ports. And I couldn't get more than 1 gigabit per second total traffic. If I had 8 streams with 122 megabits per second, so each Ethernet port had 244 megabits per second on upstream and downstream, I had over 1% of packet loss, so it's not so good. And the CPU was almost 100%. But with the traffic of 60 megabits per second, the CPU was not so high. It was about 50%, but I already had 0.1% of packet loss, so it's also a bit uncomfortable for me. The CPU already starts to drop some packets, even if it's not fully busy. So the total performance was less than 500 megabits per second when the packet losses were noticeable. So there is a solution, and it is called the switch chip. The switch chip is included in many new router board devices. Almost every new router board device that has multiple Ethernet ports, if they are 100 megabit or gigabit Ethernet ports, the router boards have the internal switching chipset that allows us to do the switching using the hardware, not the CPU. And from Router OS version 6, this is important because some people just stuck at the earlier Router OS versions and they don't know it. VLAN trunking is possible using the internal switching chipset. These are some examples. We have 4 main chipsets used now. We have 8316 used in, this is a gigabit chipset used in some rack mount, the big router boards. We have 8327 used, for example, in router board 2011 or 751G. And there are 100 megabit switching chipsets, like 8227, which is another switching chipset used in router board 2011, but only used with the last 5 Ethernet ports. So the first 5 ports use the gigabit switching chipset, 8327, and the last 5 ports use 8227, the 100 megabits switching chipset. We have also 7240 with the older devices. I hope you all get the free router board when you registered here. You got the 951 UI router board. And I'm not quite sure about it because on the wiki page, Mikrotik states that these router boards have 7240 switching chipset, but if you look inside in the configuration, it says that it's 8227. It's a bit better switching chipset, as we'll see. And we have also some other switching chipsets that don't support VLAN trunking. They are just simple, transparent switches between ports. And this can be made, for example, in the old 433 ports. If I want to check what switching chipset is included in my router board, I just need to open the switch menu and just check. There you see I have 2 switching chipsets in my router board. 1 gigabit and 100 megabits, so it must be router board 2011 with these 2 switching chipsets. And how do I turn it on? Assuming that the configuration of the router board is blank, there is no default configuration, I just open the interface's Ethernet menu and look for the 2 columns. The switch column is read-only. This is the information for me, which of the interfaces belong to what switching chipset. So for router board 2011, again, I have Ether 1 to Ether 5, and the SFP port belonging to switch 1, and the rest, Ether 6 to Ether 10, belonging to switch 2 group. And I have the second very important column, master port. If all master ports are none, this means that the switching chipset is not activated now. It's not working. All the interfaces just are connected to the CPU directly. What I need to do to turn the switch chip on is to set a master port for any interface. For example, I just take the Ether 2 interface, and I select that the master port for the interface would be Ether 1. I have this situation, and I want to bridge Ether 1 with Ether 2. So I set for the Ether 2 the master port to be Ether 1. That will activate the switch chips the switch chipset, and how many ports will be active in the chipset when I set this. How many ports? No, it will be 3 ports actually. Because Ether 1 and Ether 2 will be connected to the switching chipset, but also the switching chipset will be connected to the CPU. You see, we had this situation. Every physical port is connected directly to the CPU. But now when I set the master port for Ether 2 to Ether 1, these 2 ports will be connected to the chipset, and the chipset will be connected to the CPU instead of the Ether 1, of the master port. So it looks now like this. So just changing one master port field changes the internal configuration like this. The master port decides on which interface the CPU will see the switching chipset. It will see in Ether 1. And there we had Ether 2 before. Now there is something like an empty wire. Now the CPU cannot see anything on Ether 2 because it's just empty, like this. So, a few very important facts. Of course, I can only choose master port that belongs to the same switching chipset as the port I'm configuring. And also, there can be only one connection between the CPU and the switching chipset. Of course, if I have 2 switching chipsets, the configuration is separate for each of them. But for one switching chipset, I have only one connection. So there is only one master port possible in one switching chip. I cannot set different master ports to Ether 2 and different master ports to Ether 3. If I had any master ports configured on a chipset, it must be the same master port, only one. And the ports, the master and slave, let's call them slave ports, are totally equal. There is no difference between Ether 1 and Ether 2 in my example. They are just equally connected to the switching chipset. The only difference between master and slave is what interface the CPU will see connected to the chipset. If I set Ether 1 to have master port be Ether 2, so if I changed it 180 degrees to the opposite situation, then the only thing that would change would be this connection. The switching chipset will be connected to Ether 2, the CPU. And that's it. Nothing else changes with the master port. And notice the names of the interfaces, because there is some difference between those names here. These are the names of interfaces the central processor unit, CPU, sees. And these, Ether 1, Ether 2, are the names of physical ports the switching chipset is connected to. So if I configure Ether 1, IP address of Ether 1, for example, I configure this interface on the CPU, connected to the switch. And if I configure ports properties, I configure these ones. This Ether 2 is not the same as this Ether 2, and this Ether 1 not the same as this Ether 1. These are the interface names, and these are the physical ports names. They are called the same, but they are not the same. Okay, let's just see some examples. This is example configuration that comes to us by default with the home router boards from Mikrotik. Like 2011, like our 951, by default, when they have the simple configuration, the Ether 1 is the gateway to the internet. So it has DHCP client turned on, and the Ether 1, the gateway port, goes directly to the CPU. And the switch chipset is used to switch Ether 2 to Ether 5, these 4 ports. And the master interface for them is Ether 2. So if the IP address, the DHCP server is configured it is configured on Ether2 master interface. It's called Ether2 master just for us to be sure that this is master and the rest is the slaves. Also, the Ether2 interface here can be bridged with the wireless interface. It's not a problem, but we always use Ether2 interface here. The Ether3 to Ether5 on the CPU are not active. We cannot do anything with them. We use only the master port here, because the rest of the physical ports is managed by the switching chipset. This is the default configuration. And if we want to add the ports to the switching chipset, we just set for each of them the master port to be the first of them. That's all we need to do. But now this switch works transparently, like a small switch you can buy for a few dollars in a shop. It's not aware of the VLAN tags that go inside the packets. They just transfer the packets to every port, if the destination MAC address is okay. But we can use our switch chips to trunk VLANs also. This is our last example, when we tried to do a VLAN bridge using the CPU. So we had two trunk ports, Ether1, Ether2, transferring the targeted VLANs, 33 and 44, and we had access ports 3 and 4. The Ether3 was an access port in VLAN 33, the Ether4 was access port in VLAN 44. And we created two different bridges in CPU, added the ports, and we had the switch with VLANs using the CPU. Now, using the switching chipset, it is also very simple. We just configure the Ether1 and Ether2 ports with proper VLANs and just say that these ports are the trunks, and we configure VLANs on Ether3, Ether4, and tell the switch that these ports are access ports in the VLANs. How do we do it? It's very simple. We have the VLAN menu in the switching. Of course, this is the same switch window as before. So we select from the main menu, we select switch, and there is the whole configuration of the switch. In the VLAN menu, we add our VLANs. So in our example, there will be two VLANs, VLAN 33 and VLAN 44. And we select all the ports that will be members of the VLAN. It doesn't matter if they are trunk or access ports. We just select all ports that are members of the VLAN. So for example, for our VLAN 44, these are ports Ether1, Ether2, and Ether4. We just select them and click OK. And by default, it changes nothing, because each port has the VLAN mode set to disabled. So our switch chip, our ports, are not aware of the VLANs. So we need to change also the mode. So in the ports configuration, we go to the port menu. We just change the configuration of each port to be either trunk port or access port. If we want to have a trunk port, we change the VLAN mode to secure. It means that no other VLANs, that only the VLANs configured by us can pass the port. And we change the VLAN header to add if missing. So every packet going outside with this port needs to have the VLAN tag. So this port is trunk with these two settings. And the same goes to Ether2 port. And for Ether3 and Ether4, we configure them as access ports. Access port also have VLAN mode as secure, so only one VLAN is possible on the interface. And we select the VLAN header as always strip, so no VLAN tag can be in the packets going outside the port. Only Ethernet frames without VLAN tag will go outside this port. And we also need to specify the default VLAN ID. This is something that is usually called PVID on the switches, on the manageable switches. This is the same here. This is default VLAN ID. So what VLAN will be the VLAN for packets coming without VLAN tag from this port. So this was the configuration of the trunk port. VLAN mode secure and VLAN header add if missing. And for every access port, we configure VLAN mode secure and VLAN header always strip. And we specify the default VLAN ID. This is the same VLAN ID as the VLAN the port belongs to. And that is all. Now we have our switch chip configured to pass the VLANs. No hybrid ports are possible. I know many people ask about it, and I think almost everyone knows that we cannot have trunk ports. But we cannot do it with the software bridge also. We cannot have one VLAN untagged and the rest tagged and switch the VLANs with different ports. It's not possible. Okay, how about the speed test? I repeated the same speed test, so with 8 UDP streams coming equally from one port to another. And here you see the Ether 1 to Ether 4 physical ports almost reach their physical possibilities, almost 1 gigabit per second for each port, for incoming and outcoming. It's full duplex. And the CPU is still less than 10%, so the CPU is doing its normal job. The CPU seems not to notice the traffic that is going through the switching chipset. So that's a perfect situation. Okay, so if we compared it, later I had 0.1% of packet loss with total traffic of 480 megabits per second. It was 120 megabits per second on each Ethernet port. 120 megabits up and 120 megabits down on each port. Now I have almost 1 gigabit up, 1 gigabit down. The total traffic is almost 4 gigabits per second. And the CPU is not bothered with the traffic. And another very useful feature, I don't know if you noticed it, from Router OS version 6.5, we can see the traffic statistics from the switch ports. So here I see the traffic, RX and TX of the port, but this is the physical port connected to the switch chip. CPU is not aware of the traffic, but it shows the statistics here. We can check the interface, double click it, and we will see the traffic statistics, the statistics of all errored packets, of packets with small, medium, big size. All the statistics are now available. And this is a great feature. I know many people didn't want to use the switch chip, but they used bridge instead because they could see all the statistics from every port. Now it is possible with the switch chipset, so it's not a problem anymore. Okay, the last thing. What if I wanted to also route the VLANs? I had only the switch chip with these Ether 1 to Ether 4 ports configured, so it was just a simple switch. But what if I want to have my CPU also connected to the VLANs? For example, I need to do a routing between VLAN 33 and VLAN 44. Or just connect them to the world, to the internet with the Ether 5, which is not used now. So I just need to do the same as for trunk port, almost the same. For example, like Ether 1 and Ether 2 are configured. I configure the same, the port, which is called the CPU port on the switch chipset. So in the chipset, I have now ports Ether 1, Ether 2, Ether 3, Ether 4, and CPU. CPU is the connection between my switch chipset and the master interface, which is now Ether 1. And I configure it the same. I set the VLAN mode to secure. The only difference is that I that the VLAN header option, I will leave it as is. Because if I change it to add if missing, the Ether5, the port that is not belonging to the switch group, would stop working. Don't ask, it's just like this. We need to set the VLAN header as leave as is with the CPU port. And of course, we need to add the CPU port to the VLAN configuration. So the CPU port is the member of VLAN 33 and 44. And then in interface VLAN configuration, I just add VLANs to the master port, to Ether1. So I go into configuration of interface VLAN, and on Ether1 I add two VLANs with tags 33 and 44 on interface Ether1, which is the master. Okay, and one simple question. What would change if Ether3 was the master port? Not Ether1, but Ether3, for example. Can I do something like this? Because Ether3 is configured as an access port on VLAN 33. Can I set the trunk on Ether3? Yes, of course, because this Ether2 is not the same as this Ether3, sorry. This Ether3 is not the same as this one, Ether3. This is the name of the physical port, that is access port in one VLAN. And this is the name of the master interface that connects the CPU to the switching chipset, to the port called CPU. This Ether3 is not the same as this. And we should always have this in mind, and we need to feel the difference because we can get lost without it. So we just configure the VLANs on the master interface, and everything is that simple with the switching chipset. And the very last thing, of course, every manageable switch on which we can log in offers us the simple diagnostic tools like hosts table or MAC address table. The table where all the MAC addresses, the forwarding database of the switch, can be seen. On Mikrotik, we can do it on the switching chipset using the host menu. We can see what MAC addresses are visible on what Ethernet ports, or we can even set the static entries. And as we see, everywhere we have this VLAN ID 0, because Mikrotik treats all the MAC addresses the same in all VLANs. So if Mikrotik learned that, for example, this MAC address 35 is on Ether2, it will assume that this MAC address is on Ether2 for each VLAN tag. So it doesn't matter if the traffic comes in VLAN 33 or 44, if it is directed to the MAC with the 35 ending, it will go out using the Ether2 port. If you want very advanced configuration, when one MAC address is on different Ethernet ports using different VLANs, we need to set the option independent learning, which was shown earlier. So our Mikrotik switch will have separate versions of the table for each VLAN ID. But there is a limitation. There is no speed limitation using the switch chip, but there is only a hardware limitation of number of MAC addresses and number of VLANs that can be used. The detailed information are, of course, on Mikrotik wiki page. And usually we can have 2,000 host entries, means 2,000 MAC addresses that can be learned by our switch chip. For Etheros 8227, it's 1,000 entries. So it's total number of host entries. If we set the independent learning for each VLAN, of course it will be each entry or each VLAN will be counted as a part of this. So as long as we don't have as many host entries, as many MAC addresses in our local networks, the switch is okay for us. And also we have some advanced features like mirroring, so we can copy all the traffic from one port to another port or to CPU just to sniff it to make some advanced statistics. Or we can set more specific rules, for example, blocking some MAC addresses, blocking some types of traffic, for example, blocking DHCP packets. We can do it also with the rules that can be configured on switching chipset, but we don't have time to speak about it now. But I hope you see that this is really easy. The switch chip is really easy in use. There is nothing to be scared of. And I hope if you didn't use the switch chip because you didn't know how to configure it, or because you didn't know if it is working at all, yes, it is working, and it is working very well. And I suggest you using it if you can. And I think that's all. Thank you very much. Any questions? Oh, did Normis mention that there is a free beer?
Thank you for reminding me. I wanted to